Hello, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. We have started with the network analysis and control systems with module 1 first chapter, that is basic circuit elements. In that, we have already started with introduction, circuit components, definition, sources of electrical energy, source transformation and general network transformation. In the previous video, we have already studied mesh analysis. In this video, we will study node analysis. Node analysis, we will start with the generalized form. We'll prove it, the node analysis. In the node analysis, if you see here, in mesh analysis, what we need to do, we used to current the mesh currents like I1, I2, I3. But in node analysis, we'll consider the node voltages. This point will take as one node, another point. You can take any of the node, but here for here we have to cast this as first node and here as second node. Based on the question, we can change the nodes, and we will take one more important is that we'll consider one side of the circuit as reference or ground, ground or zero we'll consider, okay, in node analysis. These two things we need to remember in node analysis. For node analysis, we use KCL. For mesh analysis, it is KVL. For node analysis, it is node analysis. Currents pass through the nodes, incoming and outgoing currents. We'll use KCL. While taking KCL, first we'll consider KCL at the node 1. If you see here, I is an incoming current to the node 1. I is an incoming current to the node 1. So, we will take plus I. And I1 is coming out of the node, minus I1. I3 is also coming out of the node, so minus I3. I2 is also going out of the node, it is minus I2 equals to 0. Which in terms of potentials and admittances. Admittance is nothing but Y. Y admittance, and impedance is the inverse. Inverse of the impedance is admittance. Nothing but inverse of the resistance is the admittance. Okay. Then we know that I1 is what? Y1 into E1, then Y3 into E1 and Y2 into E1 minus E2. Why? Because it is between two nodes, 1 and 2. So E1 minus E2. Okay. Then equals to 0. Actually, it is E1 minus E2. If you take as here, if you have doubt like this, that why here E1 minus E2, if you take here, this is E1. If you think this is 0, actually it is E1 minus 0 into Y1 it is. But 0 it is not required. So Y1 into E1 minus Y3 into E1. We can write. But if there is another potential that side, like it is E2, second node, so we need to take it as Y2 into E1 minus E2. I1 into E1 minus E2 equals to 0. So if you take common E1, you will get Y1 plus Y2 plus Y3, and E2 common minus Y2 you will get, that is equals to I. I will be sent to one side. This will be first equation. At node 2, what happens? At node 2, if you see, the current I2, where is the current I2? I2 is going towards the node. As it is going towards the node, it is plus I2, and I4 and I5 are going outside of the node. So it is minus I5 and minus I4 equals to 0. And if you see Y2 is nothing but with respect to second node we are taking. So E2 minus E1 actually we need to write. Or else we can even write nothing but E1 minus E2. It is Y2 into E1 minus E2 minus Y5 into E2 minus Y4 into E2 is equals to 0. Then after rearranging, we get the second equation, second node equation, that is minus Y2 into E1 plus Y2 plus Y4 plus Y5 into E2 is equals to 0. These two equations, if you consider, you can write the matrix form. Same like in mesh analysis, how we took Cramer's rule as an Cramer's rule, and we find I1 and I2. No, here Cramer's rule we can use and we can find E1 and E2. Okay, for finding that, what we'll do, we'll write this y1 plus y2 plus y3 as first one, then minus y2 as second, then minus y2, then y2 plus y4 plus y5, and the next in the matrix, in the form of matrix. It is multiplied by what? E1 into E2. E1 into E2 is equals to, the right side part is I and 0. I and 0. By using Cramer's rule, how we will find in mesh analysis? What we do, I1 is equals to 1 delta 1 by delta. No, here nothing but E1 is equals to delta 1 by delta. Same formula is same, but E1 we are finding here is E1. That's it. E1 is equals to 1 by delta. What we want E1. E1 means what we need to do, first column needs to be replaced by this one, I and 0. The second column is same. For E2, what we need to do, the second column need to be replaced by I0. If you see here, the first column will be y1 plus y2 plus y3 and minus y2. Delta means what? Taking det matrix, finding det of this matrix. If you find the det of this matrix, like multiplying this two minus multiplying these two, you will get the det. You will get the det, and putting those delta values and this value, you will get E1 and E2. What we should need to do? This into this minus this into this. If you get delta, you will get. And the generalized node equations can be written as node equation is YE is equals to I. There it is E is equals to I into Z. Here it is YE is equals to I. This is for mesh and this is for node analysis. This is for mesh analysis. Why? Because here it is YE. Why? Because it is the admittance. Admittance is the inverse of what? Impedance. So YE is equals to I. If you put in the place of Z here, you will get this node equation. E is equals to I by 1 by Y. If you see, I is equals to E Y. See, I is equals to E Y. You will get this. That is the difference. That is the generalized node equation for node analysis. Using Cramer's rule also you can solve. In the same way in mesh analysis, how we have done using calci also you can solve. We will say some so that it will be more clear for you. We will see a question here. Determine the current flowing left to right through the 15 ohm resistor. The current flowing through 15 ohm resistor we need to find. How we can find, we will see. We take here node V1 and node V2, as already in the question it is given. If it is not given, we need to take, then we need to take reference to 0. One side we need to take 0 volts. We need to do in node analysis, and we need to apply KCL to node 1, that is V1. If you see, this is incoming current. If you take these as outgoing currents, these we need to consider. As there is a current source, you consider that only as incoming current, so it will be easy for you. The sum of incoming currents equals to sum of outgoing currents, no KCL. So incoming current is 2 and it is in the same direction, so we will take plus 2, that is equals to V1 by 10 plus V1 minus V2 by 15 ohm and V1 15 ohm. Then if you calculate this, you will get 5V1 minus 2V2 is equals to 60. Now we will take KCL to the second node. The 0 volts is same. This 0 volts need to be considered like a ground we need to give. Then for the second KCL to node 2, if you see here 4 amperes if you take it as incoming incoming node, and these are outgoing nodes, then the 4 amperes in this current shown here is in same direction, so plus 4, that is equals to addition of the outgoing nodes. Outgoing nodes are what? V2 by 5 and V2 minus V1 by 15. Why? Because with respect to V2, in the same V2 we are considering, that is node 2. So first we need to take V2 voltage, V2 minus V1 by 15. If you calculate, you will get V1 minus V1 plus 4V2 equals to 60. And later on, after finding V1, these two equations, we use Calci for finding V1 and V2. V1 is 20 volts, V2 is 20 volts, or you can use cancellation method. Current through 15 ohm is V1 minus V2 by actually 15 ohm, that is resistance R, V by R, but 20 minus 20 is 0 amperes. So it is 0 amperes, even though 0 by 15 is 0 amperes. Okay, then this can be found even using Cramer's rule, as we have seen in the previous slide. I'll show how to do even using Cramer's rule. If you feel easy Cramer's rule, you can use Cramer's rule also to solve. And if it is given in exams like for 10 marks, then better to use Cramer's rule so that you will gain good marks. If for Cramer's rule, by Cramer's rule, what we need to do? First we need to write the equations. After writing the equations, write in the form of matrix. The generalized form of the node analysis is YE is equals to I. YE into E is equals to I. Then write in the form of matrix 5, minus 1, 2 and 4. Minus 2 and 4. V1 and V2, 60, 60. Then V1 if you want, 1 by delta into, for the V1 what we need to do is, the first column need to be replaced by this. So 60, 60 minus 2, 4. For V2, the second column needs to be replaced by 60, 60, this right side column. Then 5 minus 1 is same. After that, for finding V1, what we need to do, that is this 60, 60 minus 2, 4 is nothing but what? Delta 1. And 5 minus 1, 60, 60 is delta 2. Nothing but delta 1 by delta and delta 2 by delta. First we need delta value. For finding delta value, what we need to do? Take this matrix and 5 4s are 20 minus 2 minus 1 into minus 2 plus 2. So 20 minus 2, 18. You got delta value. Now we can find V1 and V2 easily. For finding V1 and V2, V1 is equals to, you need to take det of this. That is 64s are 240 plus minus of minus, that is plus 120, that is by 18 you get 20. In the same way V2, 5 into 60, 300 minus of minus. Why? Because minus 60. 300 minus minus of minus 60. It is that 300 plus 60, that is 20. So in like this also we can find V1 and V2, and the next procedure to find the current is same. I is equals to V1 minus V2. We will get 0 amperes. Even using Cramer's rule also you can do. Better if they ask for 10 marks or like that, you can use you use Cramer's rule so that you will get good marks. Or if it is asked for less marks, then you can directly use Calci or cancellation method. You can get the values. Then we have, for the circuit figure, determine the nodal voltages V1 and V2. Okay. For this circuit equations nodal V1 and V2, we need to find again. It is same. It looks same, no? One only difference is the current here. It is a ulta. It is going out of the node. We will see how to write the equations. They have already given the reference point and V1 and V2 also. If they have not given, we need to take. V1 and V2 is given. Now if you see, 5 is going outside of the node. We'll apply KCL to node 1 outside of the node, and if you take these two nodes are coming inside, then minus 5 outgoing nodes minus 5 is equals to why? Because it is opposite sign. Actually what it is, incoming nodes equals to outgoing. Okay, let us not confuse. We'll think that current is going in this way and these two currents are going outside. As you can see, as it is going inside but the current is opposite, we'll take minus 5. Summation of incoming nodes should be summation of outgoing nodes. Outgoing nodes is V1 by 5 and V1 minus V2 by 5. As we are taking it is an incoming node, it is current is opposite sign, so we'll take minus 5. You will get 4V1 minus V2 is equals to minus 75. First equation. Now we will consider the second side. The next node. This is incoming node and outgoing nodes. As the incoming node, what we consider in the current passing in the same direction, in the symbol in the same direction, we will take +2. Here -5 why we take this, it is opposite what we are considering, but here we are considering the same side, so +2 only. +2 V2 by 4 and plus V2 minus V1 by 15. If you solve, you will get -4 V1 plus 19 V2 is equals to 120. Solving 1 and 2, you will get V1 as -18.125 and V2 as 2.5. They asked the nodal voltages V1 and V2. That's it. Cramer's rule also can be used. Cramer's rule also can be used for finding V1 and V2. But for now, using calci, you can directly get the values. Using Cramer's rule, if you feel Cramer's rule is easy, you can use Cramer's rule also to find the equation. Nothing but these two equations need to be written in the form of matrix and find the values. Determine the power supplied by the dependent source of the figure. Power supplied of the dependent source. The power supplied by this dependent source 3I1 we need to find in this equation. In this circuit, how we will see. First, we'll consider this node point as V1. They have not given, so we'll consider, and ground this as ground. After considering, consider this as V2. Why? Because we want power across this 3I1. So if you consider this as V1 and this as V2, it will be easy for us to calculate the power across this. After considering, we apply KCL to node 1. While applying, if you see, 15 ohms is going inside the node and we are considering this in this direction only. And if you consider these are the output outside, if they are moving outside of the node, then summation of incoming current, that is 15, equals to V1 minus V2 by 1 plus V1 by 2 you will get. And if you calculate those all equations, if you calculate that equation, what you will get? What you will get as 30 is equals to 3V1 minus 2V2. First equation we got. KCL to node 2. We will apply KCL to node 2. If you see, 3I1 current dependent source is going inside towards the node, and these two are going outside of the node. We will consider. If you consider in that way, then 3I1 summation of incoming nodes, that is 3I1 equals to V2 minus V1, as we are taking with respect to V2, node 2. So V2 will write first, V2 minus V1 by 1 plus V2 by 3. It is going outside, so V2 by 3. If you calculate, you will get 9I1 is equals to minus 3V1 plus 4V2. And if you see, I1 is where I1 is present. I1 is present near 2 ohms. As I1 is present near 2 ohms, I1 will be equals to what? V1 by 2, no? See, here I1 is present here. They have mentioned in the question itself. I1 is equals to V1 by 2. The voltage across I1 is V1 by resistor R, V1 by 2. If you substitute that, you will get this the equation, that is 0 is equals to 15 V1 minus 8 V2. If you calculate equation 1 and 2, why? Because 1 and 2 are in the terms of V1 and V2. 1 and 2 are terms in terms of V1 and V2. If you solve them, you will get V1 as minus 40, V2 as minus 75. And if you we need the power at 3I1. So we need to know I1 value. So I1 equals to what? I1 equals to V1 by, here I1 is equals to, if you know, if the equation what is given, I1 equals to V1 by 2. V1 value we know, minus 40 by 2. We will get 20 amperes, minus 20 amperes. So power supplied with dependent source, 3I1 it is. So power supplied is what? Power P is equals to V into I. V is what? V2. V2 voltage is passing through this. So V2, it is at node V2, no, 3I1, V2 into current, how much it is? 3I1 is the current. It is given. I1 value you know, that is minus 23, and V2 value also you know. You will get 4.5 kilowatt as the answer. It is very easy. You need to understand the concept. That's it. Incoming currents, outgoing currents, how to calculate power, the formulas you need to know. So you can easily calculate the power, or whichever the question they will ask. You should know the node analysis and mesh analysis. Based on that, you need to know KVL and KCL. How we need to know how properly we will apply KCL and KVL, only we will get the values perfectly. Now we will see the next question. Power supplied by the dependent source. I have took now another type of question. similar to the previous one, but here that time it was 3I1. Here we will take now 3Vx. How to solve? We will see now. If you see nodal analysis, considering V1 and V2 is same, but here what I have done, as in the question itself 3Vx is given, no, so we can consider this point as Vx directly. Why? Because the same voltage will be passing here also, so Vx directly we can. Why V2? If you take V2 also, later on we need to take that V2 is equals to Vx, but why here anyway Vx is there, so take here itself as Vx node and this is V1 node. Node 1 what it is? Incoming 15 amperes, outgoing that is V1 minus Vx by 1, then V1 by 2 we will get. Then if you calculate, 30 is equals to 3V1 minus 2Vx is the first equation. Up here apply KCL to node 2, that is node X. If you apply, current is moving towards the node. This is outside, you can consider, take this as outside now. You can consider anyway, but if there are current sources, no, consider that first. So it will be easy. As the current source is here, as it is going towards the node, take this. So minus. If it is ulta, then take minus 3Vx. As it is going in the same direction, 3Vx is equals to Vx minus V1 by 1 ohm plus Vx by 3. You will get. After finding that, you will get the equation, second equation for finding V1 and Vx. Second equation is what? 0 is equals to minus 3,1 minus Vx is second equation. As we got in terms of V1 and Vx, we can easily solve 1 and 2 and find V1 and Vx. We can use here Cramer's rule, or you can use cancellation method, or you can use calci also for finding this. After finding this, what we need to do? We want power supplied. Power supplied, how we will calculate? Power supplied, P is equals to what? P is equals to V into I. Here V is what? It is already given as V is Vx, and I, the I value, this is current source, no, the value of current source is 3Vx. It is not voltage source, it is current source. The current source value, I dependent current source value, it is depending on the voltage value. Voltage dependent current source it is. So 3Vx. So 3Vx square. 3Vx square means Vx value we already got. If you substitute that, you will get P value. See how simple it is. You need to understand the formulas are same what we are using in all the questions. What is the thing is, you need to know how to calculate it. Okay. Next question. In the circuit figure, determine current labeled I. Current labeled I with assistance of nodal analysis technique. Same. Current we need to find across the 5 ohms. We'll find now that. First 5 ampere. We will already V1 and V2 are given. Node we need to consider the references, that is 0 volts. After considering, apply KCL to node 1. As 5 amps is going towards the node, you take plus 5, that is equals to outgoing nodes is V1 by 1 ohm and V1 minus V2 by 5 ohm. You will get as 25 is equals to 6V1 minus V2. Now we will take KCL to node 2. KCL to node 2. What you will get? KCL to node 2 is, as if you take this current source is going towards the node, then this outside the node and this outside the node. If you see, we are taking ulta of the direction it is moving. So we need to take minus 4. Minus 4 is equals to V2 by 2 and V2 minus V1 by 5. If you calculate, you will get minus 40 is equals to minus 21 plus 7V2. After calculating, by solving 1 and 2, what you will get? By solving 1 and 2, you will get V1 and V2 values. 3.375 and minus 4.75. You want current label across the V1 and V2 across this 0.5 ohms. How you will get? I is equals to V1 minus V2 by 5 ohms. V1 minus V2 is what? 3.375 minus of minus 4.75 by 5. You will get 1.625 amperes. I is equals to V by R. No, directly get we got already V1 and V2. If you subtract V1 minus V2 by R, you will get the current flowing through V1 and V2. That's it. Now we'll go to next. For the circuit figure, determine the value of voltage labeled V1 and the current labeled I1. We need to find V1 and I1. As you can see, I1 is just floating out. What it means? There will be no current flowing. So I1 will be 0. See, here I1 is 0 as it is not connected and left free. So, no current passes. So, I1 is equal to 0. By inspection, by seeing the circuit only, you will get to know that I1 is 0. We need to find now V1. To find V1, what we need to do? Same, apply KCL to node. We'll take this as a VA and this as VB, or you can take this as V1 or V2, it is your wish. But I have considered now here VA and VB. I'm taking here VA because it is not like you would need to take V1, V2 only. You can consider any way, but there is some, here it goes potential. You can take VA, V0, V1, V6, this as V5, your wish. But simply you take V0 and V1 or V1, V2, VA, VB, initial values, VA and VB. After taking, you will consider the reference point also 0. After doing this, what you need to do? Apply KCL to node A, first node A. If you see 2 amps current is going towards the node and you think this is going outside the node, this is going outside the node. Towards the node is 2 amps, yes, it is equals to, outside the node is VA minus 3 ohms plus VA minus VB by 1 ohm. We got. Then after doing this, what you will get? After calculating this, you will get in terms of VA and VB. That is 6 is equals to 4 VA minus 3 VB. Now we should write the voltage KCL to node B. If you see, if you consider this is incoming node, current is going in this way, this is outside and this is outside. If you take, then as you can see the current is going opposite to the thing what we have took. So we will take minus 4. So it is a summation of the incoming current, that is minus 4, that is going opposite minus 4. Outgoing current sum is VB by 3 and VB minus VA by 1 ohm. Okay, if you solve that, you will get the second equation. What is the second equation? You will get as minus 12 is equals to minus 3 VA plus 4 VB, second equation. Solving 1 and 2 using Calci or Cramer's rule or cancellation method, you will get VA and VB. You want V1. V1, if you want V1 across what you want, V1 across this, we want potential, not current. Remember here, you want potential V1. If you want current across VA minus VB, what we will do? I is equals to V by R. That is I is equals to VA minus VB by R you used to do. But you want voltage means what we need to do? Nothing but VA minus VB. That's it. Want voltage. So VA minus VB if you do, you will get directly the voltage. If you want current through that 1 ohm resistor, then we need to do I is equals to VA minus VB by 1 ohm. But here we want voltage. So VA minus VB if you do, it's enough. VA minus VB if you do, it's enough. So I have solved some of the questions. Different kinds of questions also have done in node analysis. In others also have done how much our efforts have put. I have brought different questions which will through from textbook only, so that it will be useful for your main exam. In exam, different kinds of questions will come, so you need to know the concept. So please practice the questions whatever I am giving, whatever I am doing. Do use pen and paper to solve, so that will be easy. Practice these questions. This question I have already solved this type of question. So this question you can compare with whatever I told and you can do, you will get the values. Then power dissipated, this kind of question also I have solved. Please solve this, and if you have any doubt, please comment in the comment section. And as I told, after completing of first module, I will upload the PPT of the whole module in the form of PDF, so that you can study and you can practice. And these are the next two questions. Similar questions I have already solved in this video, so please solve. And if you get still more any other questions, if you not only in this video, if you have any other question, you have doubt, you please send me that. I will see and I will try to solve. You put that in the comment box, I'll try to solve and I will send. I'm stopping the video here. If you see introduction, circuit components, definition, sources of electrical energy, source transformation, general network transformation, mesh and node analysis. So basic circuit elements, that is first chapter of first module is done. Now we are left with the second chapter. I will start my videos with the second chapter. After this I'm going to upload the second chapter itself of the first module. Till here, mesh and node analysis, basic circuit elements, first chapter, first module is completed. If you have any doubt till now, you please do comment. This source transformation, general network transformation, mesh and node analysis, these three will be based on the basics what we have studied in the first part of the of this video. This is you need to know the circuit components, how mesh, loop and all. So don't miss any of the video. Please watch, and if you have any doubt, please comment. I'm stopping the video here. As you can see, we are done with the basic circuit elements. We will start with network theorems. There are 4 network theorems. I'll be starting in the next video. Thank you. From Sri Sai Tech Edu YouTube channel, Read Lead Success. Keep reading.